Hello guys and welcome to my final lesson on polynomials. Today we look at lesson 3, which is on factor theorem. Now factor theorem states that for something to be a factor of something else there must be no remainder. So this is an extension to remainder theorem, which we looked at in the previous lesson. So for example, if we did 10 divided by 2, then we get 5, which is a whole number. There's no remainder. Therefore 2 is a factor of 10. So, if we did, say, 7 divided by 2, well the answer to that is 3.5. So 2 is not a factor of 7, we don't get a whole number, we get a remainder. So the idea is, if there's no remainder, therefore that is a factor. So we need to apply this to an exam style question. And an example I've got here says, show that x minus 2 is a factor of x cubed minus 5x squared plus x plus 10. So the first thing we do, just like remainder theorem, is make our bracket equal to 0. So x minus 2 equals 0, so x is 2. Moving that across. Then we substitute in our value of x. And just like with remainder theorem, we're proving in this case that x minus 2 is a factor. So if we're using proof, we need to show every step of the working out. So we can't just jump straight to the answer. We need to substitute 2 into here. But we need to show what we're doing. So 2 cubed minus 5 multiplied by 2 squared plus 2 plus 10. So the next step of this, 8 minus 5 times, that's going to be 4, that's 20, plus 2 plus 10. And of course, this will come to 0. 8 minus 20, that's minus 12. Add 2 is minus 10. Add 10 is 0. Okay? Now, this could be enough for the mark. However, we do need to state the obvious at the end. With proof, we have to state what we've done. So the last line of this working out would be, as there is no remainder, x minus 2 is a factor. And that's it. That's that question done. And the second question is very similar. If you want to have a go at that yourself, it might be a good idea to pause the video, have a go, and I will go through it straight afterwards. Okay guys? Right, hopefully you've had a go at home. So the question says, show that 2x plus 1 is a factor of f of x equals 2x cubed minus 3x squared plus 4x plus 3. So the first thing to do is make this bracket equal to 0. So we get 2x is minus 1, so x is minus 1 divided by 2, minus a half. Once again, following what we've always done, we substitute that value of x into the polynomial. Remember to write f of minus a half, just showing that we're doing a function of this value, we're substituting it in. That just shows what we're doing for the proof. Now this is a harder question because we have a fraction which we're substituting in. So we're looking at maybe 2 marks for this in an exam. 2 multiplied by minus a half cubed minus 3 multiplied by minus a half squared plus 4 multiplied by minus a half plus 3. And it is worth showing all these steps. I know you might be able to jump straight to the answer, or maybe you can jump to this step here. But it is worth writing this out just to show exactly what we're doing, make it clear to the examiner so that there's no way they can take marks off you. Okay? So, minus a half cubed. Well, it's going to be a negative if it's cubed, and it's going to be minus 1/8. Multiplied by 2 is minus 2/8. Minus 2/8 will simplify to minus a half. Minus a quarter. Okay? 2/8 is minus a quarter. Now we're subtracting from this. 3 multiplied by minus a half squared. Now minus a half squared will give us positive a quarter. Multiplied by 3, 3 quarters. Okay, we're subtracting that number. Plus 4 multiplied by minus a half. Well, that's just going to be minus 2. Okay? Plus 3. Now, we could jump to the answer, but we have fractions, so I would now simplify the fractions out and then jump to the answer. So minus a quarter minus 3/4 is minus 4 over 4, so minus 1. Minus 2 plus 3. Minus 1 minus 2, that's minus 3. Minus 3 plus 3 indeed gives us 0. So there we've proved that that is the case. Now hopefully you've realised that we've actually missed something out here. What we've missed out is this statement, the summary that we have to write at the end of a question in this form. We have to write this just to prove that what we've done is shown that x minus 2 is a factor. It's just stating the obvious, but we have to do it because we might be deducted the mark if we don't write that. So it's always worth writing, as there is no remainder, two x plus 1 is a factor. And that's enough, okay? We've now proved that these two are factors of the polynomials, okay? So these two divisors are factors. So that's my third video on on factor theorem, an extension to remainder theorem. In the next lesson we'll be moving on to a different topic. This is the end of polynomials, quite a short topic. Hopefully you understand exactly what's gone on. If you don't, then please put a comment below. And if you have liked the video, then please subscribe to my channel. I'll be doing a lot more AS videos on Core 1, and then I'll be moving on to Core 2 videos. So thanks a lot guys, and I'll see you in the next lesson.